All right, everyone, welcome to Planetarium Online from the Jennifer Chalsty Planetarium at Liberty Science Center. I'm Mike, the Planetarium Director, and our program is 5 Planets in One Night. Now, before we get going, I wanted to mention a couple of things. First of all, because we have such a great turnout from around the planet, I wanted to say a bit about where Liberty Science Center is. So we're very close to the Statue of Liberty in Jersey City, New Jersey, and right across from Lower Manhattan. And it's very accessible from New York. And so once we do reopen, it'd be great to have everyone come and join us at our dome. Our dome is a converted domed theater, became a planetarium 2.5 years ago, and is in fact the largest planetarium in the Western Hemisphere at about 90 feet. In that theater, we use the Digistar 6 software to recreate the nighttime sky. And the folks who produce Digistar, Evans and Sutherland, have allowed us to use the same software to bring the nighttime sky to you on your laptops and desktops during this time of closure. Also, the whole mission of our Science Center and our planetarium is to inspire the next generation of engineers and scientists. So we're hoping that our programming here and elsewhere can lead folks to explore the possibility of careers in science and engineering. Astronomy is a great field, an exciting, expanding field right now. Also, we are a nonprofit, and we do our best to do as much as we possibly can in these challenging times. If you do feel like you'd like to support us by donating, any amount of donation is always appreciated. You can donate at lsc.org, donate anytime. So with that said, we're going to begin our program by going to where all astronomy has its origins. We're going to be going, first of all, to the sky you'd see this very evening, about 1 hour and 45 minutes before sunset. So looking towards the western sky, here's what you would see this evening. So here it is, 6:13. There is the sun hanging low in the sky. And we're going to have to go till at least a half an hour after darkness before even the brightest of the dots of light appear in the sky. So let's go ahead and go into the evening. We'll stop first of all at 8:30. We love our sun, but it's got to get out of the way before we can see the night sky. So we're going to stop for a moment here at 8:30, look over towards the western sky, and try to find the brightest dot that is there in the western sky. There's actually 2 bright dots, but one of them is both one of the planets we're searching for tonight and is the single brightest dot at minus 4.32 magnitude, the brightest dot you can see in the sky. So this dot is right there. This is the planet Venus. Now don't confuse it with another but not quite as bright dot hugging the horizon here at 8:30. This here is the brightest star in the sky, the dog star Sirius, but that is quite a bit dimmer than Venus. Venus is the 3rd brightest thing in the sky, so the sun is the brightest, then the moon, then Venus. And also, special deal, and this is why we're doing a show today. Look over towards Venus, and tucked just below it, do you see a second dot right there? That is the elusive planet Mercury, which for tonight will be tucked just below Venus. You can actually use Venus as a guide to find Mercury. Now they say that 1 person in 1,000 sees Mercury in their lifetime and knows they're seeing it. So if you all go out tonight and find this little dot of Mercury tucked down there below the brighter dot of Venus, you all can be in that 1 in 1,000 club that sees the planet Mercury and knows they're seeing it. So check that out to try to catch that. I'm showing you the sky right now at 8:30 because if you have a lot of buildings or trees and so forth in your way, which is a big problem here in the great Northeast, you can at least try to catch it at 8:30, both of these objects, before they duck behind the buildings. But let's keep on going till it gets completely dark. So we're stopping here at 9:30 tonight. And by 9:30 it's fully dark. Although also you wind up having the planet Venus there and Mercury kind of hanging close to the horizon. Now Venus is blazingly bright. Venus is so bright for two reasons. It is generally our nearest planet, as it is tonight, and also it's covered in shiny reflective clouds that reflect light very well. Venus was long ago identified with love and beauty, but when you get to Venus, there's a different story. The clouds contain choking carbon dioxide, there's droplets of sulfuric acid in the clouds, and occasionally bursts of lightning 25 times a second. Now when you get down to the surface, okay, the good news is that things are calmer. The winds actually begin to stop. The winds that rage in the upper atmosphere at 200 miles an hour do die off. But down here on the surface of Venus, you might be hoping to get some relief from the winds because it's a stultifying 860 Fahrenheit all the time on the surface of Venus. That's because the clouds in the dense atmosphere act like glass in a greenhouse and trap heat on the surface. So down here on Venus, it is always hot enough to melt lead, 860 degrees. Amazingly, two Soviet spacecraft, two Venera spacecraft, survived for about an hour when they landed on Venus, one in the 70s and one in the early 80s. And there is enough light to see. Now, the U.S. had a different mission called Magellan that actually mapped the planet Venus from orbit and was able to provide a detailed sense of the geography of our sister planet Venus. So Venus consists primarily of rolling plains, like you see here. But in addition to that, there are high outcroppings. One debate that was only resolved recently: does Venus have active volcanoes? And the answer appears to be yes. Information from the Venus Express by the European Space Agency and others has confirmed there are at least 100 volcanoes on the planet Venus. So here's our sister, a very different sister though from planet Earth. It is the same size as Earth, the same mass, but stultifyingly hot. The atmosphere is as dense as it would be a half a mile down in the ocean. It's also a little oddball thing about Venus. It takes 243 Earth days for one day on Venus. It takes that long to turn once on its axis. So it has the slowest day in the solar system. So with all these factors, even though it's our sister, our nearest planet, the same one in size to us, it is an utterly different sister. You can't imagine two worlds more different than Earth and Venus in many ways. So returning to our evening sky, we're again looking towards the sky in the west at 9:30 tonight. There again is Venus. And then tucked down below Venus tonight, you can catch the planet Mercury. Now, Mercury and Venus are the two planets between us and the sun, and they're conveniently gathered together tonight, very close together for your observational purposes. They have a number of things in common. They both are lacking in moons. Neither one of these planets has a moon around it. They both have really slow days. A day on Mercury is about 60 Earth days. And yet, they're also vividly different. It's kind of great, wonderful how wildly different each planet is from every other planet. Now, Venus and Mercury are going to be just about 1 degree apart from each other tonight. It still may be very helpful to have a telescope or at least a pair of binoculars to get a good view of the two of them. But they'll only be 1 degree apart this evening. Now, in case you're wondering, as I always did when I was beginning, what 1 degree is, if you just take your pinky finger and hold it at arm's length, the width of your pinky is about 1 degree. So that's how close these two planets will be to each other this evening. So as I was saying, all the planets are wildly different from each other. And although there are some things that the planets have in common with each other, Mercury is a very, very different world from Venus and from the Earth for that matter. It resembles a big version of the moon, in fact. We've set a couple of missions to Mercury. So without any atmosphere, craters that formed long ago have never been worn away on Mercury. Now, because it spins so slowly, when you're in the daylight, the temperature soars to 750 Fahrenheit. And at night, with no air to hold the heat in, it plunges down to minus 250. So 1,000-degree difference between night and day on the planet Mercury. Compare that to Venus, which has no variation. Again, on Venus, it's always 860 degrees Fahrenheit. Every world, a unique personality. So we're going to lose Venus very quickly. In a few days, it'll be plunged into the light of the sun. So what's going to happen, here we are again tonight, but night by night, Venus will be a little bit lower. And by the end of this coming weekend, by the 26th or so, it'll be lost in the light of the setting sun. And actually on June 2nd, it's going to pass right in between the Earth and the sun. Mercury, however, is going to climb higher. Tomorrow night, the 22nd, Mercury will be where my arrow is, and it'll be a little higher the next day and a little higher the next. The thing is, you won't have the beacon of Venus after tomorrow to try to spot it. So that's why tonight and tomorrow night would be great times to try to pick it out with a handy-dandy guide of the great beacon of Venus. But Mercury will be with us until early June, getting a little higher in the sky at the same time that we lose the planet Venus entirely. So how convenient. You do have the two planets nearest to the sun clustered together in the sky over in the west tonight, and for that matter, tomorrow night. Now we're going to turn around, stop briefly with the northern sky. We quite often get the question, how or where can I find the Big Dipper tonight? So if you look towards the north, if you're here at the latitude of New Jersey, the Big Dipper never sets. It's always in the sky, and in the sky every spring it's as high as it ever gets. So if you look up here, here we have the cup and the handle of the Big Dipper high overhead, and from our latitude, again 40 degrees north of the equator, it never sets. That's true both of our latitude, any place along that line, so a place like San Francisco or Tokyo even, you wouldn't lose the Big Dipper. The Dipper is handy for a couple of reasons. It's always in the north, always shows you where north is, but also it points directly to the North Star. It's really a handy guide to have for that. The North Star here marks off where north is, and it's the one star that stays in place. As the world turns, the stars seem to spin around it. But the North Star there, being over the North Pole, the axis of our rotation, faithfully marks off where north is the entire night. And you can use the North Star to locate north and then find the other directions from there. I mean, I know we all have cell phones nowadays and compasses and all, but still it's handy to have that as a guide to figure out exactly where north is. So Venus and Mercury are the only objects that we have in the evening sky in terms of the planets right now. So once you've seen them, you've exhausted all the possible planets in the evening sky. What you have to do is wait a little bit later to go to the morning sky, and there we'll be able to pick out the other planets. So let's go through the evening. I'm turning a little sky turning music, and as the world turns, we'll see stars set over in the southwest and rise in the southeast. So as we're getting towards just past midnight, here it is, 12:23. Here we have the great blazing dot of the planet Jupiter rising, and then next to it the planet Saturn, not quite as bright. So those come up just after midnight. If you don't want to go up to 4:30, get up at 4:30 to see everything on display in terms of these planets. You can get a quick view of them just after midnight before you, say, hit the sack. And then here we're going to stop the sky at 4:30. We're just before the first light of dawn, so we're getting towards the really long days and the short nights, but it's still dark at 4:30. And in the sky at 4:30, you can catch the Scorpion here, famous constellation that's in the morning sky right now. But what you're going to really notice is not so much the Scorpion as you're going to notice that blazing dot, the beacon of the planet Jupiter. So Jupiter is not as bright as the planet Venus, but far outshines every other dot in the sky. At minus 2.5 magnitude, it really will pop out. So anytime from 12:30 onwards, looking towards the south, the really bright thing you're going to see is the planet Jupiter. Now in 1610, Galileo, the famous Italian astronomer, invented or refined a spyglass into the first astronomical telescope. And when he turned his telescope on Jupiter in 1610, here is what he saw. He discovered 4 moons that had never been seen to the naked eye around the planet Jupiter. These are still called the Galilean moons in honor of Galileo. And they are, in order of nearness to the planet, Io. It's spelled and pronounced the same way, Io. Io, Europa. These are both moons that are about as big as the Earth's moon. Then the third one out, Ganymede, is the biggest moon in the solar system. It's bigger than Mercury, and not surprising, shines a little bit brighter than the others. And then finally, Callisto, another large moon, about 1.5 times the size of the Earth's moon. So these 4 moons were the discovery that Galileo was proudest of all the great discoveries he made with his telescope. And we now have been able to explore this planet and these amazing moons in far more detail, thanks to a whole flotilla of robots that have gone to the deep solar system. So here we have the view of Jupiter itself. So right away, a couple of things about Jupiter. We are entering the realm of the gas giant. So these are absolutely massive balls of gas, and Jupiter is the biggest of all. About 1,300 planet Earths would fit inside of the planet Jupiter. And it also has a very fast day. So a day on Jupiter is only 10 hours. So it spins quickly. There's a lot of heat coming up from the inside. And the result on the upper levels here are many, many storms and other examples of turbulent cloud behavior. The most famous storm of all is coming into view right now. Here we have the whirl of the Great Red Spot, a hurricane, but a hurricane almost twice the size of the entire planet Earth. There are no land masses to break up hurricanes on Jupiter as we have on Earth. So hurricanes go for hundreds, possibly for thousands or even tens of thousands of years. So Galileo found those 4 big moons. We know of around 80 moons now, 79 to be exact, around Jupiter. But the big ones remain still those 4 Galilean moons. So here is Io, the first of the 4. And Io's location close to Jupiter, as we saw a moment ago, really defines its fate. Being close to Jupiter, Jupiter tugs on it gravitationally. And the result is turmoil inside of this moon and giant eruptions of volcanic activity coming out of the moon. 7, 8, 9 volcanoes, sulfur volcanoes at a time. And depending on the right combination of sulfuric compounds coming out of these eruptions, the color winds up being different with different eruptions. So Io appears to be a pizza with areas of yellow mozzarella cheese-ish areas and then red tomato paste and dark green anchovy areas, all generated by this volcanic activity. So a fascinating, fascinating world, and definitely going to be one that will be explored more in the future. Now the next moon out, Europa, is also defined by its nearness to Jupiter. the tug of the gravity causes all of these cracks or lines in the surface. But despite these grooves, Europa is in fact one of the flattest places in the solar system. The slushy ice smooths out very easily, and so it winds up being almost pancake flat. Now down below the surface, we are almost 100% certain there is an ocean below the ice of Europa, about 20 miles down. And that's another thing with the tugging gravitationally churning up the insides of this moon. It keeps it warm enough to sustain liquid water. So here's a thought. Wherever we have water on Earth, we have life. So could there be some strange European fish swimming here in the oceans of Europa? It will be the source of much further exploration between now and the end of our current century. So going back to the nighttime sky again, we're still here now at 4:30 tomorrow morning. There again is that blazing dot of Jupiter. Now 4 degrees to the left, you'll find the planet Saturn. Not as bright, it's a smaller planet and twice as far away as Jupiter. Now 4 degrees is about the width of 2 fingers. You can hold your fingers up, 2 fingers will separate Jupiter from Saturn. You can use that to figure out which of the dots in the sky is Saturn. It also shines more brightly than anything else in that general area besides Jupiter itself. So Galileo did turn his telescope on Saturn as well and almost discovered the most famous feature. Didn't quite make it though. Galileo's telescope was still a pretty crude thing, and when he looked at Saturn, he noticed it was oblong, but thought that Saturn had ears or cup handles, and he died without knowing what he had almost discovered. But by the middle of the 17th century, making telescopes became a big business, and high-quality telescopes allowed astronomers to discover what Galileo had almost found, the incredibly beautiful sight of the rings of Saturn. To this day, when Andrew is here doing our commentary on our feed, show Saturn to folks in telescopes at Liberty Science Center, the most common comment we get is that it doesn't look real. It's hard to believe this thing could really exist. So that's our reaction in 2020. Imagine what it was like when Christian Huygens, the Dutch astronomer, had a good enough telescope to first reveal the rings of Saturn in the 1600s. Now, about the same time, or shortly thereafter, another astronomer, Giovanni Cassini, discovered that there was a gap or a division between the rings, and this division is still called the Cassini gap or the Cassini division in his honor. I mention these 2 other astronomers because they both gave their name to parts of this great mission, the Cassini-Huygens mission, that went and showed us Saturn in great close-up detail. So let's see Saturn really close up as it's seen through the eyes of the Cassini mission. So the cloud patterns of Saturn are more bland than the clouds that you see on Jupiter, but there's a lot of interesting patterns. There are also these beautiful complicated storms that do form in the cloud tops of Saturn. Though now and forever, Saturn is all about the rings, and Cassini showed us far more detail in the rings than we had ever seen before. The rings may appear solid, but as we get close, we'll see them for what they are. Zillions of little bits of rock and especially of ice orbiting like tiny little moons. The rings are 50,000 miles across and yet only 100 feet deep, about as deep as, well, not even as deep as a football field is wide. Razor thin and made of this very shiny, icy material, they are quite visible from Earth, unlike the rings of Jupiter, Uranus, and Neptune, which are too dark to observe from Earth. We get a good view of just how slender the rings are as we catch this view here. Also, we do have orbiting the planet Saturn, the second biggest moon in the solar system after Ganymede. This is called Titan, appropriately. And here we have the Huygens probe, named for that Dutch astronomer, going into Titan. It landed there in 2005. And what a wonderland Titan is. This appears to be a lakes district, which it sort of is, but instead of water, we have lakes of methane. It's so cold here in Titan, 300 degrees below zero, that you can't really have water existing as a fluid. But methane does act very much like water on Titan, forming lakes and oceans and pouring down as rain. So a frozen wonderland, the only moon in the solar system of the 200 or so out there that has a substantial atmosphere. In fact, the air here is thicker than the air is on our own planet Earth. So that again, the moon Titan, also discovered by Huygens with his newfangled good telescope. And again, we are back to the sky that you'd see at 4:30 tomorrow morning. So we've collected almost the entire set, but we do have the planet Mars left as well. The planet Mars is not as brilliant as the other two, but does have a faint orange hue and has intrigued us for many, many, many decades. The planet Mars has these dark markings, once mistaken for being oceans, and they seem to change with the seasons even. At one time, we were even afraid of invaders from Mars. There is an idea that if Mars was a land that had water, but if the water seemed to be shrinking, if the oceans were getting smaller, and if Mars has always meant war and aggression, what if Martians come to Earth and try to take over our planet and take our water? That was the plot of War of the Worlds, originally a novel by H.G. Wells, and 40 years after that, in the 30s, a radio play that caused quite a bit of panic, especially right here in New Jersey. So for all that, Mars can be baffling in a telescope. So it's been very great that we've sent a flotilla of landers and probes to Mars as well to explore it in more detail. Mars has two moons, almost certainly captured asteroids. So 0 moons for Mercury, 0 moons for Venus, 1 for Earth, and 2 moons for Mars. Also, Mars has polar caps. So Mars actually has a much more Earth-like personality than Venus, our alleged sister, does. The polar caps even change with the seasons because Mars has seasons. The Earth is tilted 23 degrees. Mars is tilted 25 degrees. And that tilt in both cases gives us strong variations in the seasons. So here it's wintertime in the northern hemisphere, and we have a large polar cap here at the North Pole of Mars during the chilly winter months. It's also perhaps a little refreshing that Mars has, by Earth standards, a very normal day. A day on Mars takes only 37 minutes longer than a day on Earth, compared to Venus's 243-day day. So looking at Mars close up, it is a land that does have blowing storms. Sometimes the entire planet is covered in a dust storm. And in fact, 2 years ago, when Mars was close to the sun and close to the Earth, the entire planet was blocked out by a dust storm right at the moment of its peak visibility and brightness in August of 2018. But most of the time, the air on Mars is quite clear. It's really thin. The air on Mars is 100 times thinner than the air on Earth. So just as Venus has an atmosphere that's 100 times more dense, the air on Mars is 100 times less dense than the air on Earth. But what is there is mainly carbon dioxide. You can see a little bit of the edge of the atmosphere here. A little world, half the size of Earth, low gravity. This planet also has amazing, giant geological features. Here we have Mount Olympus, or Olympus Mons, the biggest volcano in the solar system, about 2.5 times the height of Everest. It would cover all of France, or pretty much all of the state of New York. An extinct volcano. Mars was way more active geologically in the distant past. An example of that as well is the Great Rift Valley, the Valley of the Mariners we're seeing now, a crack in the crust of Mars that is 3,000 miles long. So on Earth, it would go all the way from Los Angeles to Jersey City, 3,000 miles long, 4 miles deep, mainly caused by quake activity, but also carved out by water that used to flow upon the surface of the red planet. Many observations, both from orbit and from the surface, indicate that Mars did have water flowing across its surface in the distant past. Many features show that they were carved out by rushes and flows of water, extinct ancient lake beds there. Mars is dry as a bone now, but it clearly did have water once upon a time. At one time, it was not the red planet, it was the red and blue planet. And who knows, maybe life could have got going back in those ancient times and then disappeared once the planet dried out. Whether or not Mars had life, it will have life someday because it's the obvious choice for the first human mission to a planet. Venus is unbearable, as we saw. The other planets are way too far away. So we hope sometime in this century to have a human mission to go to the red planet Mars. It'll be a big undertaking. The moon and back in the 60s and 70s with Apollo, less than 2 weeks. Mars and back is a 2 to 3 year undertaking with a human mission. So here we are again, just to note that we do have in the 4:30 sky tomorrow morning, we have Jupiter and Saturn and Mars. Mars, by the way, if you're trying to figure out how far away it is, if you find Saturn, it's about 30 degrees to the left of Saturn in the morning sky, and that's the width of 3 palms held at arm's length. So 3 palms will be the way you can mark off. So measure 3 palms from Saturn and look for a little red ember, and that will be the planet Mars, a very slight orange color. Now, an important thing that I wanted to mention is that the planets don't come back at the same time every year. The stars do. And the stars stay in the same pattern for thousands of years. And so here we have the stars that make up the Scorpion, the rival of Orion the Hunter. And the stars that form the Scorpion itself was named about 2,500 years ago by the Greeks and the Chaldeans and the Babylonians. And it's kind of amazing that we can still use these names invented that long ago for the constellations we have today. Tomorrow morning, the star Akrab's not going to go that way, and the star Antares is not going to go that way. Now, everything in the universe is moving, but the stars are so far away. They're like cars on a very, very distant freeway where you can't see much motion unless you give it a long time. The planets, on the other hand, are much nearer to us, and we can see their motion, not in one night, but within a few nights you can tell that they're shifting their positions. The planets are only millions, not trillions and trillions of miles away. And because of that motion against the starry background, the planets are not on the same cycle. They come back at different times. They're in different positions at different times during different years. If you take a photo of the sky each night for a month and then turn it into a movie, you'll actually have a time lapse showing you how the planets do this ballet against the background of the fixed stars. So we're going to do that. We're going to go from the 22nd of May into mid-June. Also try to figure out, of these 3 planets, which one moves the most quickly of the trio. So now we're going to speed things up. Beginning tomorrow morning, the stars stay in place as the planets slowly drift against the starry background. By the way, the little speed demon here, the moon goes around the entire sky once every month. And so it's worth noting, by June 8, you'll have the moon right below Jupiter and Saturn. So the morning of the 8th, check that out. And then it's going to wind up joining the planet Mars on the 12th. Now you may have noticed that Mars there is faster moving than Jupiter or Saturn. Closer to us, closer to the sun, Mars does move a lot more quickly across the sky than the outer planets do. So it's a very quick moving object, although not as fast moving as the moon itself. So also the changes in the sky, unlike the stars in the western sky we saw at the beginning of our program, These planets in the evening sky are going to be around all summer long. So in fact, if we go to the middle of August, here we are now, August 15, at a more perhaps civilized time of 11:30, there's Mars rising by 11:30. And you may want to notice also, it's looking a lot brighter. As Mars gets closer to us, it's going to flare up dramatically and rival Jupiter in brightness. So if you're stargazing this August here, or this July and August, you'll have the planets available at a little bit of an earlier time than having to get up at 4:30. And that applies also to the planets Saturn and Jupiter. They'll also be visible and nicely placed in the south by just before midnight here in mid-August. And in fact, Saturn and Jupiter will be up all evening long in the heart of the summer. So if you're thinking of getting a telescope and doing all that, now would be a great summer to do that because they'll be very well placed. It should be a very good summer for the planets. So if you had to make your choices, I would say focus on the evening sky tonight. Catch tonight the planets Mercury and Venus as they're low in the western sky because you're going to lose them really, really, really quickly. But you're going to have the other planets there in the morning sky coming around to the evening sky as we go into the summertime. So that is the end of our program, and we'll now see if there's any questions we have in terms of questions we do have from the audience. So looking over our list here, Farzana is wondering if anyone ever landed on the planets. Great question. In fact, no one has ever landed on any planet yet. We've gone to the moon with a number of missions in the 60s and early 70s, but no one has ever yet walked upon a planet. As I was saying a moment ago, it's a really big undertaking. It's going to take 2 to 3 years total for a Mars mission, maybe 8 months to fly to Mars, a year at least on Mars, till the lineup of Mars and Earth gets good again, and then another 8 months coming back. So we do hope to do it, but we're thinking it's going to be quite a long time. Why would aliens on Mars want to take over the Earth? Well, that was the roots of that idea go back to War of the Worlds, the idea, but also that Mars has always meant warfare. Maybe our active imaginations thought we saw the color of blood or fire in that pale orange glow. So the idea that Mars was the war god goes back to the Greeks and the Romans. The word martial, which means warlike, comes from Mars. So combining that idea of Mars being aggression, meaning aggression, with the idea that maybe it had oceans that were shrinking, caused H.G. Wells to postulate the idea of maybe there were creatures that would come and actually want to take over our planet. We know now there certainly is no life on Mars, probably has not ever been life on Mars. Let's see, the 5 planets in the sky. The last time we had 5 planets in the sky was back in November. And I have to check to see when the lineup's going to come around again. It should be sometime next year, I think, but we'll check on that and post it. I wanted to mention again, we are posting all of our presentations on our Facebook page. They're usually up within an hour. So if you wanted to go and either review this for where the planets are going to be, or if you wanted to catch any of our other great presentations, Andrew also gives presentations here. They're all available off of our homepage, LSC in the House. Is there potential for water on one of the Galilean moons? So that's been a really interesting development. So we just talked about Mars. In the early days of hoping to find life in our solar system, Mars was the big focus. Kind of Mars is off the table as being a home of life, we think, unless there was maybe prehistoric life. But over and over, we're discovering evidence that Europa and also Ganymede and Callisto, among the big moons of Jupiter, have under the surface oceans. And they think that maybe even Pluto has that. So it was also one moon called Enceladus around Saturn that has an underwater, under the surface sea. So we are hoping that maybe if we find life elsewhere in our solar system, it would be in the under the surface oceans of those moons out there. What if we don't have a telescope is a question in terms of observing things. So the nice thing about this, Priyanka, is that basically these planets can all be seen without needing a telescope. So even catching Mercury tonight below Venus should be pretty easy to see, although binoculars would help as well to try to pull that out. Although if you were going to try to find Uranus, Neptune, or Pluto, those are things that would require a pretty good sized telescope. Okay, Kathleen is wondering on behalf of her son how long it would take to get to Saturn if it takes 2 to 3 years to go to Mars. So a mission to Saturn would take many, many, many years, probably 5 to 10 years, depending on how you set the orbit up. So if you know the film 2001: A Space Odyssey, which is about a mission to Jupiter, they actually, in that science fiction film, put most of their astronauts into a state of hibernation so they wouldn't lose all those years of life as they were traveling for many years to the planet Jupiter. And so that is a challenge of trying to get a human mission to a distant planet, is that it can take, like the fastest trip out there ever was the New Horizons mission that took 10 years from Earth to Pluto. And that is kind of a concern that if you're going 10 years each way, then that's 20 years of your life coming and going, and that's more than we can really undertake right now. So fortunately, we've sent amazing, wonderful robots, both from NASA and from other agencies, to explore the deep solar system in our stead. So Jupiter is going to be in our sky for a long time, and so we will have that all the way around until the fall. Rena is wondering how do all planets rotate. So it's funny, Rena, that although your orbit around the sun is just a matter of how far you are from the sun. So if you're near the sun, you orbit fast, like Mercury going around in 8 days or so. If you're far from the sun, you go very slow, with Pluto going around every 248 years. But there doesn't seem to be any rhyme or reason in terms of your spin. So you have very slow-moving planets in terms of how they spin, with a day on Venus, for example, taking 243 Earth days, and then really fast-moving planets. Generally, the big balls of gas, Jupiter, Saturn, Uranus, Neptune, do tend to spin much more fast than the inner planets. Someone's asking, Holly is asking about a starry telescope. We have a lot of luck with Orion telescopes. You can check them online. Orion makes a good $100 desktop telescope that's really good for showing these things like the rings of Saturn and the moons around the planet Jupiter. If you travel to Mercury, Jennifer is wondering, would you spontaneously combust? No, we can actually build spacecraft that can withstand ferocious temperature. So the heat would kill you, as would the vacuum of space, if you didn't have a spaceship or a space suit. But we're pretty good nowadays at building spacecraft that can survive horrific hot environments. Looking over the questions here. Let's see. Patricia's mentioning that her son's favorite planet is Uranus. So we didn't talk much about Uranus. Uranus is, of course, you have to have a telescope to see it. But it's actually, Uranus and Neptune are gas giants like Jupiter and Saturn, much smaller than Jupiter and Saturn, but also much bigger than any of the 4 planets that are near the sun, the rocky terrestrial planets. Uranus' most distinctive feature, we talked about how the Earth is tilted 23 degrees, Mars 25. Uranus is tilted 98 degrees. It actually lies on its sun as it goes around, or lies on its side as it goes around the sun. Uranus also has rings. The second set of rings ever discovered was discovered around Uranus in the 70s. Some astronomers were observing Uranus go in front of a star, and right before and right after Uranus covered the star over, there were unexpected drops in the star's brightness on each side of Uranus, and that led to the discovery in the 70s that it had to have rings around it. So rings seem to be a very common thing for our gas giant planets. Teresa's wondering, has Mars always been red? Yes, it always was red in terms of having a lot of iron oxide or rust in the surface. Only in the old days, when a big chunk of Mars was covered in ocean, then it was really would have been a very blue and red planet combined. It's just with the water gone now, it's more of a red, or really, to be honest, more of an orange planet. What is the closest star to Earth besides the Sun? Prathima is wondering. So that is the Alpha Centauri system, about 4.3 light years away, or about 28 trillion miles away. Our nearest sun can't be seen, by the way, from here. So some stars can't be seen from New Jersey. But if you're down around Hawaii's latitude, it's a very bright star. It's in fact the third brightest star in the sky, and is but still so far away that light, the fastest thing we know, at 186,000 miles a second, still takes over 4 years to go from that star Alpha Centauri to your eyeballs. Someone is wondering if any dwarf planet has moons. Jayashri, I believe is the name, is asking about that. So yes, it's very common. So as you probably have heard, Pluto itself is reclassified as a dwarf planet, and that has 5 known moons around it. And also other dwarf planets whose discovery kind of led to this whole new category of dwarf planet also have moons. And so you can definitely have moons even though you're a dwarf planet, just as you can be a regular planet like Venus and not have any moons. Okay, we'll take a couple more questions. We're question how far is Mercury from the Earth? Mercury is in the range of about 45 million miles away, but it changes dramatically based on where Mercury is and where the Earth is in its orbit. But you can know between 45, 50, 55, 60 million miles away. Wenady is wondering, have I been pronouncing Uranus wrong the entire time? So that's a good question. And most of my professional career has been trying to find ways to say Uranus without getting giggles from middle schoolers. But Uranus is a pronunciation of the original deity that it's named for. Uranus is one term you hear quite often, but Uranus is the terminology that is most commonly used in describing that. Is the Earth smaller than other planets? The Earth is the biggest of the 4 terrestrial planets. So the Earth is the biggest of the 4 planets near the Sun. We're slightly bigger than Venus and much bigger than Mars and Mercury. So we're the king of our own little kingdom, although we are dwarfed by the massiveness of the planet Jupiter. And of course, there's been a lot of brouhaha over the reclassifying of Pluto as a dwarf planet, but at least now, instead of being the tiniest of the regular planets, Pluto is now the king, the biggest, size-wise at least, of the dwarf planets. So Talia is wondering for her 5-year-old, how far is Neptune from Earth? Neptune is in the neighborhood of 3 billion miles away. So it's actually kind of an easy breakdown. So Jupiter is 1/2 billion miles away from us. Saturn is 1 billion. Uranus is 2 billion. Neptune is 3 billion. And Pluto is approximately 4 billion as a general yardstick. So it's actually pretty convenient as a way to remember it. Stephanie is wondering if I've ever seen Halley's Comet. I've seen it, but the 86 appearance was one of the dimmest apparitions of that comet. So all I saw was a little itsy bitsy fuzzy patch. It wasn't as striking as any of the other comets we've had more recently since then. Okay, so we're going to take one more question, and then we'll go ahead and wrap our program up. Prathima is wondering, is the Sun a red giant? The Sun is a yellow star, yellow-white star. It'll become a red dwarf as it gets older, but it will never have enough mass to be a red giant star. And so, actually a good question here from Joanne. How do you adjust our comets? She lives in Utah. And so how do we adjust what I'm saying here in terms of time of night? And it's already taken care of thanks to the time zones. So basically the things we're seeing here in the sky that we're discussing in New Jersey will be visible at the same time because of the time zones in your area as well, give or take a few minutes. And so, and depending on whether or not you're on daylight saving time and all. So it'll be right after sunset, no matter where you are, that you'll be able to pick out the planets Venus and Mercury in your sky, for example. So with that, we're going to go ahead and wrap our program up. Again, this program will be available within an hour as a YouTube video, and you can check out all of our other programs. Again, if you could think about supporting us, we always appreciate donations. We're also, like all of us, trying to keep our mission front and center, as we're also working hard to make ends meet. Thanks to Andrew and Jeremy helping us out online in terms of the responses, and come back and join us again for this astronomy program every Thursday at 1 o'clock, or check out some of our other great online program we have from Liberty Science Center. Okay, thank you all very much.